Last but not least, this is the lie I like to tell to myself. So first and foremost, thank you all for being here. I know you must be probably tired or bored, but nonetheless, I will try to entertain you in the slot that we have. Some small things before we start. First and foremost, this presentation actually should have been a little bit bigger, but due to our time slot, I just compressed it a little bit. So we're going to talk just about one thing, Kubernetes API. But before we start, I would like to ask you a couple of things just to know how to pace the presentation. How many of you are at the beginning of working with Kubernetes, so to say working with deployments, pods, config maps, secrets? Please raise your hand. Okay, wow, you're all in the back. And how many of you are more, let's say, Kubernetes experts, maintaining on-prem clusters, building operators, controllers? Nice, nice. No, keep your hands up. Keep your hands up, please. So if you have any questions with regards to this presentation, these are the people you should address afterwards. So just look good. Cool. So our agenda will be rather short and straight to the point. We're going to talk a little bit about Kubernetes history, just briefly. Then I will share with you some personal blunders and aha moments, so to say, for maybe some tips and tricks. And why not? We're going to have we're going to have a demo, maybe because in this day and age, it's not a given thing to have a demo. And last but not least, we're going to talk about Kubernetes in today's landscape. Cool. A couple of words about me. My name is Alex. I'm a site reliability engineer at Systematic. I've been with Systematic for 3 years now. And in my spare time, I like to contribute and help others on various platforms, share my opinions. That's my handle. So feel free to reach me if you have any questions and if I can help you, of course. Now, our entry point is Kubernetes history. So Kubernetes has its roots in two, let's say, internal systems at Google, one of which is Borg, and the other one being Omega. These are some snips from the white papers. The white papers are publicly available. I highly recommend you to read because you're going to have a small gut feeling afterwards. What's the deal with Kubernetes? You're going to see things about scheduling and managing workloads. Now, a fun story, which I've recently found out. The original prototype of Kubernetes was written in Java. So it was actually a Borg cell on your personal computer. But nonetheless, afterwards, for obvious reason, it was rewritten in Go. Now, the first commit, public commit, so to say, was in June 2014, so almost 10 years ago. And after 1 year, Google donated Kubernetes to the open source. Actually, it founded the Cloud Native Computing Foundation. And here is the important part. This is a statement from Google in which they say, we are pleased to contribute to the open source cluster scheduler. That's an important thing. You're not going to see in their formulation, so to say, orchestrators or this kind of wording. And another important thing is that it's a C technology. So they were from the get-go, from the beginning. So to say, they launched the CNCF, Cloud Native Computing Foundation. For those who don't know, CNCF is an umbrella foundation for open source projects. So in here, each small square, it's a technology that addresses a specific need. So for example, Kubernetes is in here under scheduling and orchestration. So this is the current landscape. It is rather daunting. There are over 200 technologies in here, right? For various, let's say, pillars, deployment, CI/CD, monitoring, storage, so on and so forth. And after 10 years, you're looking for a job, right? And you start looking in the market. I have some recent snippets from actual job description from LinkedIn, and desired characteristics and technical expertise, excellent knowledge of Kubernetes. Technical stack, Kubernetes. Nice to have, Kubernetes. Last but not least, what your day will look like, Kubernetes. So we can all agree that in this day and age, Kubernetes is a prevalent technology. Fortunately or unfortunately, you need to know it at some level, right? And here, I would say the most important part, the entry point, is the lingo, the wording, right? So flexing, so to say. For me, I have a funny story. I was in a meeting and someone told me we need a solution that supports automatic beam packaging of our workloads. And I was, okay, so we're not talking about Kubernetes, right? And he was, no, that's Kubernetes. Because actually, that's the technical definition. If you go back to the scheduling part, the one that Google mentioned. So yeah, you can say that's a container orchestrator system, but actually, let's say the technical definition is this one. And of course, you're going to have tons of wordings, right? Naked pod, what does it mean? A pod without a controller. You're going to have workloads. So you can say the pod was scheduled on the cluster, but you can also say the workload has been scheduled. You're going to have things like sidecar containers, init containers, ambassador. So all the container architecture part. And of course, if you are in the, let's say, admin part, you're going to find things like static pods. So I would say the first thing is that you need to master a little bit the wording, right? The technical terms. Now, almost all presentations and tutorials start presenting Kubernetes with this architecture, including mine. In here, I think everybody's seen this, this picture. We have the control plane with the API server, scheduler, control manager, etcd as a data store, and of course the data plane node with all the workers. And I was like, oh, okay, so that's Kubernetes, right? That's the important thing. That's the main thing. But actually, if we were to take a look at another technology, Docker Swarm, you're going to see another Raft-based state store. You're going to have a control plane with managers, and of course, some data plane with some workers. So we can see some similarities between Kubernetes and Docker Swarm. But actually, what Kubernetes did very, very well is implementing an API on top of all of this. So even though we work on a daily basis with YAMLs, behind the scenes, there are some nice JSONs. From the internal point of view, there are some protocol buffers for serialization. And at the core of this API server is the controller pattern. How many of you have heard about the control pattern? Cool, that's nice. So this is a very simple thing. I would say it's the key in Kubernetes. Basically, the whole idea is that you're going to have your desired state in your YAML files, and then, of course, the actual state in your cluster, it might be another one. And at the core of the API server are multiple controllers, actually, but they are just simple watch loops, right? They are doing reconciliation between the desired state and the actual state. So if the actual state drifts, the controller will correct that. So you might heard about it like a reconciliation loop, watch loop, or controller. And a controller does mainly three things. Observes the desired state, then it analyzes the drift, meaning the difference between the actual state and the desired state, and then at the end it will act upon it to correct it. Now, the next thing are the operators. And this is a little bit daunting. Like the definition, the first part of the definition, it's a design pattern for extending Kubernetes API and creating software to run on Kubernetes. This is a little bit fucked up because it's run Kubernetes software on Kubernetes and the design pattern. I mean, it's not an orchestrator or what. And funny enough, if you want to know how embedded or how deep an organization is into Kubernetes, so if you go to interviews or things like that, just ask them how many custom resources do you have. Just do a kubectl get CRD. Because besides the vanilla resources like pods, deployment, so on and so forth, you might find things like harbor specific custom resources. So this is the output of kubectl get CRDs. We're going to get to this later on. But this shows exactly how much that organization is involved in Kubernetes, how many custom resources they have. And now, I'm going to try to do a demo without knowing what the operator is. But we're going to have this feeling together. Someone told me, I don't understand your demo, explain it a little bit. So it's a bit tricky. The whole idea was for me, I was playing on my local machine. And here on the right upper corner, you can see, I wanted to create my custom controller. So that's an operator. It's actually a controller, but a custom one, which tails the logs from multiple pods. Because at the end of the day, I was a little bit annoyed. Okay, I'm developing an application. I want to see the logs. But then I had to switch to another pod to see the other logs. So I wanted just one pod that aggregates all the logs from whatever pod I wanted to tail off. And of course, it has a small thing called a CRD. So let's try to do the demo, and for me not to throw water on my laptop. So, can you see? I mean, the font is okay for you in the back? Okay, perfect. So, first and foremost, the important thing that we have the documentation at our fingertips. So, I highly recommend to use actually kubectl explain. So, let's start with this one. Here, I hope you see. I'm explain the pod resource, the pod object, and here we can see two nested fields: the spec, specification of the desired behavior, so this is our desired state, and the status, which is the actual state. So if we dig a little bit deeper and look at the status, we can see the all known phases like of our pods: failed, pending, running, succeeded, so on and so forth. Cool. So now we can see that we can explain some resources. Another interesting thing is that you might have heard that Kubernetes is a compute abstraction. But what does it mean at the end of the day? It's a rather simple thing. So for example, if I want to see the sorted information about my processes, so the resource consumption, I can use top on my local machine, right? I mean, we can do a top and use CPU as a key. And that's nice I have a sorted view about it. But guess what? You can do the same thing in Kubernetes. You're going to do top. Let's choose pods. Let's take a look at the containers and sort them by CPU. And let's take the entire namespaces. So basically, we interacted very easily with Kubernetes. We did a top. You might use this command if you want to check your resource usage. But again, you can use top for your cluster, meaning for your nodes, right? Here I have just one small node, is the Docker cluster, so to say. Now, an interesting thing is that what's happening behind the scenes when we do these kinds of things. So if we increase the verbosity, let's choose an 8, here we can see a couple of things. First and foremost, I don't know if you see it, but we contact the API here on top. You can see that we have an endpoint there, and of course we have a JSON as promised. Now, so we can see that behind the scenes there's a nice API. Maybe we can do another type of request. We can do a raw request to the same API. And guess what? Let's pipe it to JQ. Boop. And we have the same result with a small difference. So to say, here we have millicores, and the return result is in nanocores. But nonetheless, now we have a feeling, okay, so there's an API behind the scenes, right? So we are interacting, I would say, with the API on 100% of what we are doing. And now, let's take a deeper look. And if we take a look at API resources, I will just make it a little bit smaller. Here we can see the entire API resources, so to say, simplifying our endpoints in our Kubernetes cluster. So the important thing is the kind. So when we see like the all known vanilla objects like pod deployments, secrets, so on and so forth, they are available in the API as a resource, right? Like, as an endpoint, so to say. And for example, when we did the top command, we actually interacted with the metrics API group. So here, let me do something else. Here, just more concrete, what we did is just we contacted the metrics API, and this API actually has two kinds, meaning two objects, the node and the pods. So, yes, sure. So just to rerun it, here, to explain a little bit what happened behind the scenes, we have an API group, meaning the metrics Kubernetes.io, which has two kinds, two objects, two endpoints, so to say. Now, let's try to extend this API, and we would like, because we're KCD, we would like to extend it with something around KCD. Just to be sure I'm not doing any strange stuff, now we don't have our API endpoint or API group in here. And first and foremost, we need the famous custom resource. So let me show you the custom resource. It looks like this. The important bits are here. This is our API group because we wanted to extend the API with we decided to call, actually I decided to call kcd.io. And of course, behind this API, we're going to have just one kind, meaning one object, namely log drain. And another important part is the spec, meaning we're going to have one property, a string called target. We're going to see later on what we're doing with this one. Now, of course, to create it, we need to apply it. Boop, boop. And now we have our new endpoint in the API. If we grep for it, it's here. But now, leveraging on what we did, oh my God, I have 5 minutes. Okay, let's go speed. Leveraging the thing that we've seen earlier, we can do an explain on our resource. So if we explain our kind, meaning the log drain object, we can see that is a resource that allows the configuration of a demo operator. So we have the CRD, we don't have the operator yet. And another important thing is the spec. In the spec, we're going to see exactly the target string that we attached, right? Now, we said that we need an operator. What's an operator? An operator, it's a custom controller, but at the end of the day, it's just a binary wrapped in an image. We need to deploy it, so we need a deployment, right? And, okay, because our application will interact with the Kubernetes API, it needs some role-based access. And for this, we're going to create some role bindings and some roles. And, oh, I forgot about the apply. And here we create a cluster role binding, because remember, our application needs to talk with the API. Now, let's deploy our application. So it's just a simple deployment, nothing fancy. Actually, our operator is just a script. So here, our pod has been created. If we take a look at it, it's just demo operator pod in our default namespace. And if we follow the logs, demo operator, here we can see that our custom controller looks for logger drain objects. So we created the API, but we don't have any objects, right? So let's create an object. Now, can you see? Cool. So first and foremost, we need to create an object. To create an object, we need, of course, a declarative approach. So our object, it's, let me put it in here. Our object, it's a log drain object. This is the name. Doesn't matter, we called it demo LD. And we need a value for the target. Someone wants to give me a value for the target? A simple word. 1 minute. 1 minute. Okay. 1 minute. Now, let's create our object, meaning we're going to do a kubectl apply. And as soon as our object is being created, our operator will pick it up. And now we can see log drain object named demo LD with specs target 1 minute is there, because our loop, it's running and says, okay, I have an object of that type of our custom resource. Now, don't forget about the purpose. I want to aggregate logs from various pods. Now, I need to create, guess what, a naked pod. A naked pod, because you messed around with the target naming, I need to update. I will create a pod, a simple Nginx image with the label, target, and the value 1 minute. Whoop. Now I think it's even less than 1 minute. And what will happen behind the scenes, as soon as my pod will be ready and healthy, the operator will pick the logs up. And here we can see the logs of our Nginx image. Even more, if we want to add another pod, we can do that. The process will be the same, 1 minute. Whoop. And basically here is just a simple web server that will going to be tailed by our operator. Coming back to slides. Now, the tricky part. So, if we just do a small recap, what's a resource? A resource is an endpoint in the Kubernetes API. So if you remember the custom resource thingy, actually we created an endpoint in the API. So at the end of the day, the API is the magical thing in Kubernetes. And of course, what's the power? Why did I show you everything? Because in this way, we can have opinionated things in Kubernetes, right? Kubernetes is actually, the entire CNCF is built around it. And guess what? With the whole platform engineering stuff, entire organization will start to build platform, teams, platform engineering, so on and so forth. But if you can do it, this doesn't mean you should do it. I mean, it's fairly easy to extend Kubernetes, but you have to think about it, about the end goal, why you would like to do that. Of course, I had another part of the demo, but I have 30 seconds. You can do you can do the same thing playing with the API from the client side. And here you can see various CLIs that you can use, K8S, Kubeshell, so on and so forth. I had a demo for this one, but let's jump to the conclusions. So, in many ways, we are working with abstraction at different layers on a daily basis. It's very important to understand them. Now, at the end of the day, Kubernetes is more than an orchestrator. It's a platform for building platforms because we can extend the API with whatever we'd like to. And a thing that people tend to forget is that Kubernetes is not a magic thing. If your infrastructure is shitty, Kubernetes will not help you with anything. So the infrastructure part is very important. And that was it. Thank you. Oh.